We were looking yesterday at dividing not rational expressions. We were looking yesterday at dividing radical expressions. Rational expressions is something we will look at doing in the next unit. And there's some basic ideas here that when you simplify, you treat almost as a checklist. First, the general procedure is that when you're dividing, you divide radicals with radicals, and that involves dividing the radicands by the radicands, and you divide coefficients by coefficients. That's kind of the general starting point. But you always want to remember that in the end, whatever you get for an answer, all of the radicals have to be simplified as mixed radicals in simplest form. So if you had root 50 as part of an answer, you're not done yet, because root 50 can be simplified by writing it or thinking of it as root 25, root 2, which means root 50 is 5 root 2. So that's one of the things in your checklist that when you think you're done, you have to make sure that you are in fact done with regards to those radicals. The other thing is your answer cannot have radicals in the denominator. Now, I don't believe that any of the questions in number 1 would leave you with a radical in the denominator. Nor do I believe any of the ones in question 2. Does 9 divide into 144? Can you help me out here? I think it must. But when you get to things like question 3, where you have, let's just pick on B, you have 4 root 90 over root 72, you can certainly simplify root 90 and you can simplify root 72, but I wouldn't recommend doing that. What I would recommend doing is saying to yourself, and you don't have to write this, but saying to yourself that root 90 over root 72 is the same as the square root of 90 over 72, which means we can whittle that 90 over 72 down to a fraction in lower terms. And sometimes when I say whittle it down, that's because that's what I end up doing. I don't necessarily get the fraction in lowest terms right the first try. I would say to myself, well, I know these are both divisible by 9. That's how my mind works. I see 90 and I see 9 times 10. I see 72 and I see 9 times 8. So this simplifies to 10 over 8. Oh, so it's 5/4. And in this particular case, we lucked out because I was going to use this as an example to tell you that we can't have radicals in the denominator, but we lucked out because root 4 is 2. So we're not going to get a radical in the denominator anyway. You end up with 4 root 5 over 2, and now the 4 and the 2 are both coefficients, so you can divide 4 by 2 and get 2 root 5. But if you were to take, we'll try D, 18 root 24 over root 162. In my mind, I'm not even going to worry about the radicals here. I'm just thinking, what is 162? What is 24 rather? Over 162. And again, there's lots of ways to whittle this down. Some of you are very good with fractions this way. I'm a little slower that way. I would probably divide top and bottom by 2. That's just the way my mind works. So I would get 12 over 81. Does 3 divide into 81? I think it does. I think it divides in 27 times. So we get 4 over 27, I think. If I divide the top of this by 4, I get, or by 3, I get 4. I divide the bottom by 3, I get 27. But can you confirm that that's right? It is, okay. So what this becomes is 18 root 4 over root 27. Root 4 is 2, so we get 18 times 2 over root 27, which we can simplify to 36 over root 27, because 18 times 2 is 36. But we are not done, okay? We are not done because all radicals need to be simplified, and we do not want radicals in the denominator. We have two things to do. We have to clear the denominator of radicals, and we have to simplify that radical if possible. And my recommendation is to simplify the radical first. Because, and I haven't reviewed this with you from yesterday yet, but to rationalize this, you would have to multiply top and bottom by root 27. And root 27, well, 27 is quite a big number. Maybe we can simplify root 27 first to get a smaller radical. And again, I'm a fan of I don't want to call this scrap paperwork because you would need to show it on an exam, I think, but just figuring out what root 27 is on the side. And it's 3 root 3. Because 27 is 9 times 3, and the square root of 9 is 3. And that means that this 36 over root 27 becomes 36 over 3 root 3. And we talked, this happened a lot yesterday. You've already divided stuff, and then you do something else and you discover you can divide more stuff. Like right now we have 36 in the numerator, which is a coefficient. 36 is a coefficient. And we have 3 as a coefficient in the denominator. Well, 36 divided by 3 is 12. So we get 12 over root 3, but now you have to clear the denominator of radicals. You're not allowed to have radicals in the denominator. So we're going to multiply top and bottom by root 3 and get 12 root 3 over root 3 times root 3 is 3. And look at that, we can divide again. Now you can take that 12 divided by the 3, that's also a coefficient. And you end up with 4, 12 over 3 is 4, root 3. It just occurred to me that I do have to address something with you outside of this lesson. I believe sometime today we're having a lockdown drill. And many of you have probably been in this school when we have a lockdown drill. If you haven't or you forget, there will be a very loud, shocking kind of siren that goes off, bleeping noise. Usually there's a strobe light that goes on. And what happens during a lockdown or a lockdown drill, it's very important that you follow the directions of your teacher or any adult in the building. But what happens is I lock the door, I close the door, I turn the lights off. If this were a real lockdown, the best thing for us to do would be to go around behind that counter and sit on the floor. And that's happened a couple times in the past. Nothing serious happened, but there was, a perceived threat, and we had to do that, and that was fine. During a drill, it's fine if we just sit in our desks and wait for it to end. Usually, there's a repeating message that says we are in a lockdown. Please follow the directions, and it repeats like 8 or 9 times. And then there'll be a message saying the lockdown has ended. If you are ever outside of the class and there's a lockdown, take a quick look around and look for a teacher, because most teachers will usually look out into the hallway, and if they see somebody there, they'll go, come on in. Okay. If you don't see a teacher, then you might want to make it into the library or someplace else. The likelihood of anything serious happening in our building is so slim, but, we take these precautions just in case. Yeah, I think that's it. Let's take a look now at any questions you have from yesterday. We'll go over more of these questions this afternoon in our regular class if you have some, but we're here now and we still have about 10-15 minutes left. Does anybody have any questions? Lynette? 5A? Certainly. H? Okay. So we have root 32 over root 18. My first thought is not, I know I can see by looking at 32 and 18 that I can tear those apart because they each contain perfect squares. But and that might end up being the quickest path, but I like to simplify fractions first. Remember, what I'm about to do, I'm doing because root 32 over root 18 is the square root of 32 over 18. So I'm able to kind of forget about the radicals for a second and just concentrate on 32 over 18. What does 32 over 18 reduce to? Well, I can divide top and bottom by 2, definitely. Rather than whittling away at it, I'm going to just ask myself, if I divided top and bottom by 2, what would I get? I would get 16 over 9, wouldn't I? Okay, so I'm not going to whittle away at it because 16 over 9 doesn't reduce any further. Which means, Lynette, that root 32 over root 18 is root 16 over root 9. And this is a very rare case, very unique case, where what we're getting is a radical in the numerator that is not even a radical. Or maybe it'd be better if I said the radical in the numerator is not irrational. It's rational number because the square root of 16 is 4. Does that make sense? And the square root of 9 is 3. So the answer is 4/3. And that's all we have to do. Now, I don't know exactly what would happen had we, simplified each of those radicals first. We could certainly explore that. Root 32 is root 16 root 2. So I'm doing this because 16 is a perfect square. And 18 is 9 times 2, so root 18 is root 9 times root 2. The square root of 16 is 4. The square root of 9 is 3. And root 2 over root 2 cancels. So, and this is always the case. This goes back to Kendra's comment about one of the examples a couple of classes ago, where it doesn't really matter the order in which you do all of these things. Which is, again, why sometimes you think you're done and you look at it and you can continue to do more stuff. Anyway, does that help? Okay. Other questions? Go ahead. 2A. So root 270 over root 10. Again, we are allowed, this is a property of radicals that we've talked about, a radical over a radical of the same index is the same as the radical of the quotient of the two radicands. A lot of terminology there. But what I'm saying is root 270 over root 10 is the same as the square root of whatever 270 over 10 is. And 270 over 10 reduces to 27. In other words, 10 divides without remainder into 270, so we end up with, this is overkill, Reagan, but we end up with root 27 over 1. I don't think we need to write over 1, but 270 over 10 reduces to 27 over 1. That means that this is simply equal to root 27, and now we have to go through our checklist. Have we divided coefficients by coefficients, or can we continue to do so? We're done. We've already divided the radicals. There's no denominator that has a radical. I don't know why you would put a denominator here, but if you did, you would put the number 1 in it. The only thing left is, can we simplify root 27? And root 27 is root 9, root 3. And again, I'm reminding you, for radicals that are square roots, I don't like writing root 3 times 3 times 3 and extracting pairs. I think it's quicker to just find a perfect square that's a factor of the radicand. So what we're getting is 3 root 3. Good? Other questions? Lynette? 5J? So 14 over root 98. Now, let's be clear here. You cannot reduce the 14 over the 98 because 14 is what I would call a coefficient, and 98 is a radicand because it's underneath a radical sign. We're going to have to, at some point, cope with the fact that we got to get rid of the radical in the denominator. So we're going to have to rationalize the denominator. I don't think at this point, and I wouldn't write this down because I'm about to erase it, I don't think this is a wise move. Well, I shouldn't say it's an unwise move. I think it's better to simplify the radical first. This will still work, but you're going to end up with 98 on the bottom, 14 on the top. You're going to have a lot of reducing to do. So instead of doing that, let's rewrite root 98 in simplest forms. Now, well, I know what the numbers are. Can you tell me which perfect square divides into 98? 49, and it goes in twice, correct? Which means that root 98 is 7 root 2. And you can see something nice has happened here. We had a coefficient of 14 in the numerator, and we have a coefficient of 7 now in the denominator, and 14 divided by 7 works out well. It works out to 2. So we end up with 2 over root 2. And I want to just talk about that 2 on the top here for a second. Again, just going off on the side here. When you're thinking of 14 divided by 7, it reduces to 2 over 1, so that 2 is on the top. What I'm saying is when you divide numbers and there's no remainder, the answer that you get is written on the top of whatever you're working on. Now what I can do, Lynette, is multiply top and bottom by the root 2 in the denominator. This is our method for eliminating the radical in the denominator, which is called rationalizing the denominator. I get 2 times root 2 on the top, and on the bottom I have root 2 times root 2, which is just 2. And again, every time you think you've checked something off the list, like, okay, I've already divided the coefficients, now we can divide them again. 2 over 2 is 1. In other words, these two 2's, I suppose we could say, cancel, and you're left with root 2, which is, I think, kind of a remarkable thing, that 14 over root 98 looks like kind of a complicated number, but it's just equal to the square root of 2, it turns out. And you could certainly determine that on your calculator. You could verify it by taking 14 over root 98 and then just taking the square root of 2. Other questions? Go ahead. For B? All right, so we have 9 root 20 minus 3 root 10 over 3 root 2. I'm just curious, how many of you see, and not everybody's going to see this, so I'm going to show you the algebraic method. How many of you see that this is 3 root 5 minus root 2? Sorry, minus root, I got to do that again. Pardon me, 3 root 10 minus root 5. Does anybody see that? And there's a number of ways to do that. Remember I told you that you could, if you wanted to. By the way, I'm not going to recommend doing what I just did, unless it's obvious to you. We said, and we looked at this when we were dealing with these problems yesterday, and we also looked at it when we were dealing with a quadratic formula, that you were allowed to cancel a number out of a coefficient as long as you cancel it out of every coefficient. You could use the same argument and say that you were allowed to divide radicals by the same thing as long as you divide every radical by that thing. So if I divide every radical by root 2, I'm going to have root 10 and root 5 on the top. If I divide every coefficient by 3, I'm going to have just 3 root 10 minus root 5. we could approach it that way. What you, I was going to show you something else, but I'm not. But let's approach it the way I've taught you. One of the things when we look at the very first expression here is we have 9 root 20, and root 20 can be simplified. I would recommend simplifying radicals first, even though everybody, after you simplify a radical and then do something else, you may have to resimplify another radical. I like working with smaller radicals. So what is root 20? Root 20 is root 4 root 5, which is 2 root 5. So I get I get 9 times 2 root 5 minus 3 root 10 over 3 root 2, which gives me 18 root 5 minus 3 root 10 over 3 root 2. Does that look okay? You're fine there. Now, at some point, we have to divide those coefficients, right? So that 18 in front of the root 5, that 3 in front of the root 10, and that 3 in front of the root 2 can be simplified. But rather than me just slashing 3 from everything, I'm going to do it the proper way to remind you that what you are doing when you cancel, I've factored a 3 out of the numerator. What you were doing when you cancel is you were canceling a factor that is common. And I still have my root 2 here. Good? Okay. So let me rewrite that. I end up with 6 root 5 minus root 10 over root 2. And now I need to multiply the numerator and denominator by root 2 to rationalize the denominator. Well, I'm going to have to multiply that root 2 by the 6 root 5 and the root 2 by the root 10, which will give me 6 root 10 minus root 20 over 2. You okay with that step? Okay. Now I go through my checklist, right? Have I got rid of the radical in the denominator? Yes. Can I cancel any coefficients? Well, I cannot cancel the 6 with the 2 unless I could also cancel with the coefficient in front of the root 20. And I can't because it's just a 1. Root 20, though, can be simplified, can't it? Root 20, and you know, at some point, I just want to say root 20 is 2 root 5. I mean, but you know what? Even me just doing that in my head opens my work up to error. I could make a mistake. Even myself. I'm not bragging, but I'm saying I've been doing this a long time and I know numbers well. But let's just make sure this is root 4 root 5 because 5 times 4 is 20. Yep. Root 4 is 2, so it's 2 root 5. And this is over 2, so I think you can see what's going to happen now. I can either factor a 2 out of the numerator and cancel it with the denominator, or I can take a shortcut and just divide everything by 2. Have a great morning, everybody. We'll see you guys this afternoon.